Buckle up, everybody, because today we are diving headfirst into the world of quantum computing.
Oh, yeah, this is going to be a wild
We're
one.
talking computers so powerful they make our current tech look like, well,
Like cave drawings.
haha, pretty much. We're using that awesome Star Talk episode with Michio Kaku and Tiffany Haddish as our guide for this deep dive.
They make a great team, by the way. I love how they explain things.
Well, yeah, it's like you never thought you'd hear a physicist and a comedian breaking down quantum physics and making it so fun.
And relatable, too.
Absolutely. And, they bring up some seriously mind-bending stuff.
Like parallel universes.
Oh, yeah, the multiverse. Turns out that's not just science fiction.
Nope, it's rooted in some real science.
Okay, so let's back up for a sec. We all know that quantum physics governs the microscopic world, right? Tiny particles and all that.
Right, but here's the thing. It's not just tea about the microscopic.
Oh, this is where it gets good.
Yeah, Kaku emphasizes that quantum physics is behind how everyday objects behave, too.
So like the chair I'm sitting on.
Exactly. It's all thanks to quantum physics.
Wow, so it's not just some abstract theory, it's the foundation of our physical world.
Exactly. It's like the rule book for how reality works at the most fundamental level.
Okay, so how does this tie back to computers?
Well, think about the computer you're using right now.
Or phone or whatever.
Right. All those devices use transistors, basically tiny switches that are either on or off to process information.
Like a light switch.
Yeah, kind of. But quantum computers use quantum transistors.
Ooh, quantum transistors.
And those can be in multiple states at once.
Hold on, multiple states, so not just on or off?
Nope. Think of it like a dimmer switch with infinite settings.
Whoa, so
Yeah.
it could be a little on, kind of on, really on.
It's more like it can be on, off, and everything in between all at the same time.
My brain hurts.
I know, right? But that's where the incredible power comes from,
Okay, so we've got these quantum transistors that can be in multiple states at once.
which leads to exponentially more processing power.
Okay, so how much more powerful are we talking?
Kaku suggests that Silicon Valley as we know it could become obsolete,
Obsolete, like gone.
replaced by atomic computers.
Wow, atomic computers, so like my phone will be a museum piece.
It's possible. The materials we use for computing could change completely.
So that brings us to this idea of quantum supremacy.
Ah, yes. The point where quantum computers surpass traditional computers for specific tasks.
And we're already there.
We are. It's not just a theoretical concept anymore.
That's kind of mind-blowing when you think about it.
It really is.
So how do these quantum computers actually achieve this supremacy?
Well, Kaku uses a great analogy. Think of a mouse in a maze.
Okay, I'm picturing it.
A regular computer has to try each path one by one until it finds the exit.
Like trial and error.
Exactly.
Yeah.
But a quantum computer can explore all paths simultaneously, like it has millions of mice working in parallel.
Whoa, talk about a shortcut.
Right. That's the power of quantum computation. It's like having a massive parallel processing system all in one.
Okay, so we've covered the basics of quantum physics, how quantum computers work, and even touched on this idea of quantum supremacy.
And how it's already here.
Right. So now I'm curious about this whole multiverse thing.
Ah, yes, the idea of multiple realities existing at the same time.
It sounds like something out of a sci-fi movie.
It does. But it's a concept rooted in quantum physics.
Seriously?
Yeah, and Tiffany Haddish even shares a funny anecdote about feeling like different parts of her are in different places.
Maybe she's experiencing the multiverse.
Uh-huh.
Yeah.
Who knows? But it's a great example of how they make these abstract ideas relatable.
It is. Okay, so if the multiverse is rooted in quantum physics, what about this whole Schrödinger's cat thing? Isn't that connected too?
Absolutely. It illustrates the concept of superposition, where a particle can exist in multiple states at once.
Like that cat that's both dead and alive until you open the box.
Exactly. It's only when we observe it that it chooses one state.
So before we open the box, the cat is both alive and dead.
In a sense, yes. It's existing in all possible states simultaneously.
Whoa, that is seriously messing with my head.
I know, right? It challenges our everyday intuition.
It definitely does. So how does that tie into the Heisenberg uncertainty principle? Isn't that all about not being able to know both the position and momentum of a particle?
Exactly. It's basically saying that you can't know everything about a particle with perfect accuracy. It's all about probabilities, not certainties.
Okay, so quantum mechanics is all about probabilities and uncertainty.
And mind-bending possibilities, like quantum entanglement.
Oh, yeah, that's another one that always trips me out. Two particles linked no matter how far apart they are.
Like they have some kind of telepathic connection.
Right, and they can influence each other instantly.
Which seems to defy Einstein's theory of relativity.
Yeah, nothing can travel faster than light. Right.
Right. But here's the thing with entanglement. While information seems to travel instantly, it's not usable information.
So no faster than light communication.
Not quite. It's
No.
more like a random correlation that we can't control.
Okay, so entanglement might not be a way to send messages faster than light.
But it's still a pretty wild phenomenon, and it's being used to develop new technologies, like super secure communication systems.
So there are practical applications for this mind-bending stuff.
Absolutely. And this is just the tip of the iceberg.
That's what's so exciting. We're just starting to scratch the surface of what's possible with quantum computing.
And it's already impacting so many different fields.
Like medicine.
Absolutely.
Oh.
Dr. Kaku talks about how quantum computers can revolutionize drug discovery by simulating the behavior of molecules with incredible precision.
So we could develop treatments for diseases that are currently incurable.
It's definitely a possibility.
Wow. And what about energy? Could quantum computing help us solve the climate crisis?
Potentially, it could lead to breakthroughs in renewable energy technologies like more efficient solar panels or even new ways to capture and store energy.
And space travel?
Oh yeah. Kaku talks about how quantum computers could help us design more efficient propulsion systems and navigate through space more effectively.
So interstellar travel might not be so far-fetched after all.
The possibilities are endless.
So when will this all be available to the average person? Are we talking years, decades, centuries?
Well, Kaku suggests that we'll likely access quantum computers through the internet, similar to how your phone connects to servers today.
So it'll be like having a supercomputer in our pockets.
Essentially, imagine the things you could do with that kind of power at your fingertips.
It's mind-boggling. But with all this power comes potential risks, right?
Absolutely.
Huh?
We need to be mindful of the ethical implications of such powerful technology.
Like, what happens if quantum computers become powerful enough to break our current encryption methods?
That's a huge concern. All our online data could be vulnerable.
It's a bit scary to think about.
It is. And that's why we need to have these conversations now while this technology is still developing.
We need to make sure we're using it for good, not for harm.
Exactly. And that's what makes this deep dive so important. We need to understand both the incredible potential and the potential risks of quantum computing.
So we can make informed decisions about its development and use.
Exactly. This is a technology that could shape the future of humanity. So we need to be prepared.
Okay, so we've covered a lot of ground in this first part of our quantum journey, from the mind-bending basics to the potential risks and ethical considerations.
But we've also seen how quantum computing is already making a real difference in the world.
And we're just getting started.
Stay tuned for part 2, where we'll explore even more mind-blowing possibilities like negative energy and wormholes.
I can't wait. It's going to be epic. Okay, so in part 1, we talked about all sorts of crazy quantum stuff.
Parallel universes, quantum supremacy.
Oh, yeah, and that cat that's both dead and alive.
Schrödinger's cat. Classic.
But now I want to delve into some of the more, I don't know, out there concepts.
Like negative energy?
Yeah, Dr. Kaku really piqued my curiosity with that one.
It does sound like something straight out of science fiction.
Right, like warp drives and stuff.
Well, it's not quite that simple, but Dr. Kaku emphasizes that negative energy is a real thing.
Wait, seriously?
Yeah. Scientists have actually created tiny amounts of it in labs.
No way. So it's not just some theoretical concept.
Nope. It's a real phenomenon.
Okay, so what exactly is negative energy? And how does it tie into quantum computing?
Well, think of it like this. Normal energy, the kind we use every day, has a positive value. It attracts things, like gravity.
Okay, that makes sense.
Negative energy, on the other hand, has a negative value.
So it repels things.
Exactly.
Yeah.
Like anti-gravity.
Whoa, okay. Now my brain is officially starting to hurt.
I know, it's a lot to wrap your head around. But here's where it gets really interesting.
Okay, I'm listening.
Dr. Kaku suggests that negative energy could be the key to stabilizing wormholes.
Hold on, wormholes. Like those theoretical tunnels through space-time?
The very same.
Are you telling me that we could potentially travel through wormholes?
It's not as far-fetched as it sounds. Einstein's theory of general relativity predicts that wormholes can exist. But the problem is they're incredibly unstable.
So like you try to go through one and it collapses before you get to the other side.
Exactly. It's like trying to walk through a doorway that keeps disappearing.
That's a bummer. So how does negative energy help?
Well, theoretically, if you could surround a wormhole with enough negative energy, you could prevent it from collapsing.
So it'd be like holding the doorway open.
Exactly. You'd create a stable passage through space-time.
Okay, this is blowing my mind. So we're talking about actually traveling to other stars, other galaxies.
Potentially. But like I said, we're still in the very early stages of understanding negative energy and wormholes.
It's still pretty amazing to think about, though,
It really is, and it highlights just how much we still don't know about the universe.
and how much potential lies within the quantum realm.
Exactly. It's like we've just scratched the surface of what's possible.
Okay, so we've got wormholes, negative energy. What other mind-blowing possibilities are we looking at?
Well, we've already touched on artificial intelligence.
Right, and how quantum computing could take AI to a whole new level.
Imagine AI systems that can learn at an unprecedented rate and solve problems that are currently impossible for us to even comprehend.
That's both exciting and a little terrifying.
I agree. It's like opening Pandora's box. We need to be extremely careful with how we develop and use this technology.
Because the potential for misuse is huge.
Absolutely. Dr. Kaku even mentions the possibility of quantum computers creating autonomous weapons systems.
You mean like robots that can make life or death decisions without human intervention?
Exactly. It's a sobering thought, and it underscores the need for ethical guidelines and regulations for quantum computing.
We need to make sure that this technology is used for good, not for evil.
Absolutely. And that's a conversation that needs to happen now, not later.
Right, because the future is being shaped as we speak.
And it's up to all of us to make sure that we're shaping it in a responsible and ethical way.
Okay, so we've talked about the potential benefits and risks of quantum computing, but how is it actually being used in the real world right now?
Well, that's a great question. And it's the perfect segue into our next topic. Let's move beyond the theoretical and explore some of the tangible applications of quantum computing in fields like medicine, material science, and of course, artificial intelligence.
Wow. It's amazing to think about all the ground we've covered in this deep dive.
Yeah, from the weirdness of quantum physics to the possibility of things like wormholes and negative energy.
And those are just the theoretical possibilities. What about what's happening right now with this technology?
It's already having a big impact in so many areas.
Like in medicine.
Oh yeah, especially with drug development.
That's the one that really got me thinking.
Yeah, Dr. Okaku talked about how quantum computers can simulate how molecules work.
Like really precisely, too, right?
Exactly. And that means we can develop new drugs way faster and with better results.
So instead of spending years and tons of money in the lab,
We can run simulations on a quantum computer and see what works best.
so it's like a virtual lab.
Yeah. And not only is it faster, it's also more accurate.
So we could create drugs that are more effective and have fewer side effects.
Exactly. And maybe even personalized medicine tailored to your specific genes.
Now that would be revolutionary.
It would. And it's not just drugs. Think about material science.
Oh yeah, like building stuff.
Imagine designing new materials, atom by atom.
So we could create like super strong but lightweight materials for spacecraft.
Exactly. Or super efficient solar panels for clean energy.
The possibilities are endless. And what about artificial intelligence?
Now that's where things get really interesting.
Yeah, what happens when you combine the power of quantum computing with AI?
We're talking about AI that can learn super fast and solve problems we can't even imagine.
Like AI that can design those new drugs we were just talking about.
Or optimize traffic flow in cities, or even predict natural disasters.
That's pretty amazing, but also a little scary.
Yeah, it's a lot of power, and we need to be careful with it.
We definitely need those ethical guidelines we talked about.
Absolutely. This technology has the potential to change the world, and we need to make sure it's for the better.
So what can we do? How can we make sure quantum computing is used for good?
Well, knowledge is power. The more people understand this technology, the better.
So we need to educate ourselves and others about the potential and the risks.
Right. And we need to support research into the ethical implications of quantum computing.
And push for regulations that prioritize safety and transparency.
Exactly. We're at a crossroads with this technology, and we need to make the right choices.
This has been an incredible deep dive.
Yeah, we've gone from the tiny world of quantum particles to the vast possibilities of the future.
It's clear that we're on the verge of something truly revolutionary.
A quantum revolution.
And it's up to all of us to shape that revolution and make sure it benefits humanity.
So keep learning, keep asking questions, and keep exploring.
Because the future is quantum and it's waiting for us to discover it.
And that's a wrap for our deep dive into quantum computing.
Thanks for joining us.